introduction to polynomial. Okay, let us see what is the definition of polynomial at first. A polynomial p of x in one variable x is an algebraic expression in x of the form a n x raised to n plus a n minus 1 x raised to n minus 1 plus etc. plus a2 x square plus a1x plus a naught, where a naught, a1, a2, etc. an are called constants and an not equal to 0. That is, at least one of this coefficient, one of this ans are not equal to 0 in order to become a polynomial. That is, p of x will become a polynomial only if at least one of these an not equal to 0 in this expression. Okay. Now, what is this a naught, a2, etc. an? They are respectively the coefficient of x raised to 0, x square, etc. x raised to n. So, what is the coefficient of x square? That is a2. What is the coefficient of x raised to n? That is an. That is, these terms are coefficient of x raised to 0, x square, etc. x raised to n. Also, these terms are constants. Each of an x raised to n, an minus 1 x raised to n minus 1, etc. a naught with an not equal to 0 is called term of the polynomial p of x. Okay, that is, these are called term of this polynomial. So what is a polynomial? Polynomial in a one variable x is the expression of this form where a naught, etc. an are constants. Constants means what? That is 1, 2, 3, etc. That is numbers. And that is, a polynomial is a combination of numbers and the variable x. Okay, that which is arranged in this format, and these are called the term of the polynomial p of x. Here an is not equal to 0. Now, what is the degree of a polynomial? Okay, before that, powers of x are non-negative integers for a polynomial. So, you should see whether the powers of x are non-negative integers in order to become this expression into a polynomial. Okay, that is, what is a non-negative integers means? 1, 2, 3, etc. 0, 1, 2, 3, etc. that are non-negative integers. So, the powers of x must be a non-negative integer. Now, what is the degree of the polynomial? Degree of the polynomial is highest power of the variable in the polynomial. Okay. Which is the highest power of variable in the polynomial, that is known as degree of the polynomial. So, for example, so what is the degree of this polynomial? So, at first check whether it is a polynomial or not. So, it is of this form, that is a n x raised to n. Instead of n, we have here x raised to 6 minus 2x plus 3. Okay. What is our condition here? At least one of the an not equal to 0. Here an is not equal to 0. That is, at least one of this is not equal to 0 here. Also, all the powers are positive integers. So, this is a polynomial. What is the degree of this polynomial? That is highest power of the variable. That is, what is the highest power here? 6. So, the degree is 6. Now, the second one, what is the degree? Y raised to 5 plus 2y minus 1, which is degree is 5. That is the highest power, that is 5 here. This is also a polynomial since an not equal to 0. What is this an here? Here a5 not equal to 0. This is a polynomial in variable y. Okay. Now, this is not a polynomial y. We want the powers of x are non-negative integer. Here the power is negative, that is x raised to minus 5. So, this is not a polynomial. Since it is not a polynomial, there is no degree here. Next, root x plus x square plus 3 is also not a polynomial. Why? The root x power is x raised to half. X raised to half is not a integer. So we want the powers of x as a non-negative integer. Now this is also is not a polynomial, that is 1 by x minus 1. Why? It is not of this form. Okay, in order to become a polynomial, it should appear in this form. Introduction to polynomial, main classification. So we are going to see what are the main classification of the polynomial. At first, the classification is based on degree. Based on degree, the class polynomial is classified as linear polynomial, quadratic polynomial, and cubic polynomial. That is, a polynomial of degree 1 is called linear polynomial, degree 2 is called quadratic polynomial, degree 3 is called cubic polynomial. Okay, that is polynomials of degree 1, that is the highest power of x is 1, then it is called as linear polynomial. Okay, so what are the example? 5x plus 3, y minus 2, 6x plus 3, 6x all have degree 1. That is the highest power of x is 1. Now, what is 5x here? That is, sorry, what is the coefficient of x here? It is 5. The coefficient of x can be any term, but the highest power of x is 1. Then that is called as linear polynomial. Now what about quadratic polynomial? Polynomials of degree 2 is called quadratic polynomial. Example, x square plus 3x plus 5, ax square plus c, 3y square plus 2. Now what is cubic polynomial? Polynomials of degree 3 is called a cubic polynomial. Okay, for example, x cube plus 3x plus 5, y cube plus y square minus 5, 9s cube. These all are polynomials of degree 3. That is, highest power of x is 3. Here it is a polynomial in the variable s here. Okay. Now another classification is also based on degree, that is constant polynomial. That is polynomials of degree 0. If there is no x term in the polynomial, then it is called as constant polynomial. For example, x 3 6 5a etc. Next classification is based on terms of the polynomial. What are those? Monomial, binomial, trinomial. So if a polynomial have only one term, then it is called as monomial. Two terms, that is binomial. Three terms, that is trinomial. Polynomial with one term is called a monomial. Example, 5x y cube 6x raised to 100. Its a degree can be anything, but it has only one term. Then binomial is of two terms. 5t raised to 9 plus 10t, ax square plus c, 6 h square plus 2. Now what is the coefficient of x square is? X square here, that is a, that is a and c are constants here. Now trinomial is polynomial of three terms is called trinomial. That is x cube plus 9x square plus 5, y raised to 10 plus y square minus 5, 9x cube plus 9x plus 5. Okay, these are trinomial, that is polynomial with three terms. Next, another classification of the term is zero polynomial. That is polynomial having 0 as only term. Then it is known as zero polynomial. That is, it has only term 0. But its degree is not defined. Why? That is, anything multiplied into 0 will give 0. That is 0 x raised to 100 is 0. 0 y raised to 5 is 0. So its degree cannot be defined if a polynomial having 0 as only term. Okay. This is an important thing. For a zero polynomial, the degree is not defined. Geometric meaning of zero of a polynomial. Okay. Now we have to find what is the geometric meaning of zero of the polynomial. That is, what is the connection between zero of the polynomial and the graph. Okay. So what is a zero of the polynomial? A real number k is said to be the zero of polynomial p of x if p of k equal to 0. That is, instead of x, if we put k, then we will get p of k equal to 0. Then that is called zero of a polynomial. Okay. For example, let p of x equal to x minus 1. So instead of x, if we put 1, then we will get 1 minus 1, which is equal to 0. So what is the 0 here? That is 1. X equal to 1 is the 0 of the polynomial. So what is the 0 of the polynomial here? That is x equal to 1. Now, what is the relation between this 0 and the graph of the polynomial? Sorry, that is, and the graph. For that, we have to draw the graph at first. So in order to draw graph, at first we need the points. That is, when x equal to 0, p of x, that is y-axis is taken as p of x-axis is taken as x itself. That is, if 0, x equal to 0, then p of x equal to negative 1. That is 0 minus 1 minus 1. If x equal to 1, then 1 minus 1, 0. X equal to 2, 2 minus 1, 1. X equal to negative 1, then minus 1 will gives negative 2. X equal to negative 2 minus 2 minus 1 will gives negative 3. So we get our points here. Now we have to draw the graph. For that, at first, take the axis here, that is x-axis, and y-axis here, that is this is y-axis and this is our x-axis. Now what is the point here? That is 0 comma negative 1. That is, at first point is between 0, x0 and y negative 1. What is that point? X0 and y negative 1. That is, this is that point with coordinates 0 and negative 1. Okay. Here y coordinate is 0, sorry, x coordinate is 0 and y coordinate is negative 1. So which is our first point? Then what is our second point? 0 comma 1, that is, sorry, 1 comma 0, that is x coordinate is 1 and y coordinate is 0. This is that point. Next, this point is 1 comma 2, that is x coordinate, sorry, 2 comma 1, that is x coordinate is 2, that is this point, and y coordinate is 1, that is intersection of these 2 points will gives 2 comma 1. Now negative 2 comma negative 1, that is intersection of negative 2, sorry, negative 1 comma negative 2, that is intersection of x coordinate negative 1 and intersection of y coordinate negative 2 is this point. So we get our points here. Now next we have to draw the graph joining these lines. So this is our graph here. Here, what is the relation between 0 and the graph? That is, here the graph is intersecting at only one point in the x-axis. What is that? Is this is x-axis and graph is intersecting at only one point in the x-axis. What is that point? X equal to 1. So what is the 0 of the polynomial? What is the geometric meaning of 0 of the polynomial then? That is, if we draw the graph of that polynomial, x-axis will intersect with that graph at 0 of the polynomial. Okay. That is where the graph of the polynomial and 0, sorry, the polynomial graph will intersect only at 0 of the polynomial in the x-axis. Okay. That is the point where the graph of the polynomial and x-axis is meeting is its 0. Here we have only one 0 and the graph intersect at only one point, that is intersection of graph is at 0 of the polynomial. So that is the connection of 0 of the polynomial and graph. Okay. So in the next example, p of x equal to x square minus x minus 2. Okay. This is the polynomial of degree 2. Then at most it may have two zeros. That is, if it is of degree 2, it may have at most two zeros. That is, the maximum number of zero the polynomial can have is 2. That is, it can have no zeros, 1 0, or at most it can have 2 0. Maximum number of zeros the polynomial will have is 2, not more than that. Okay. In order to find 0, put x square minus x minus 2 equal to 0. In order to factorize this polynomial, we have to know two numbers, that is, whose product is negative 2 and sum is negative 1. What are those numbers? 1 and negative 2, that is 1 into negative 2 will give negative 2. 1 plus negative 2 will give negative 1. Now, we can factorize this polynomial into x plus 1 into x minus 2, which is equal to 0. Which implies x plus 1 equal to 0 and x minus 2 equal to 0. So, what are those numbers? That is x equal to negative 1 and x equal to 2. So, the zeros of the polynomial are x equal to negative 1 and x equal to 2. Next, we have to find the geometric meaning of zeros of polynomial. So, we have to draw graph. Before that, we can plot the points. That is, if x equal to 0, then what is the value of y? That is negative 2. If x equal to 1, then 1 minus 1 will give 0. That is again negative 2. If x equal to 2, that is 0. That is 2 square 4, 4 minus 2, 2, 2 minus 2, 0. That is x equal to 2 will give 0. Then if x equal to negative 1, then negative 1 square 1, 1 minus 1, 0. Sorry, 1 minus negative 1, that is 1 plus 1, that is 2, 2 minus 2, 0. Again negative 2 will give negative 2 square, that is 4. 4 plus 2, sorry, 4 plus 2 will give 6. 6 minus 2 is 4. So we get our points for plotting the graph. Next we can plot the graph. So we get, so we take x-axis and y-axis here. Then x-axis is x itself. Y-axis is the value of p of x. Now, what are those points? That is 0, negative 2. That is when x equal to 0, y is negative 2. That is this. Sorry, at first we can take this point. That is negative 2, 4. That is the intersection of x equal to negative 2 and y equal to 4. What is that point? That is x equal to negative 2 is this point. Y equal to 4 is this point. Intersection of these two will give this point. Next, negative 1, 0. That is x is negative 1 and y is 0. That is this point. Intersection of x equal to negative 1 and y is 0. That is this point. Next point, 0 comma negative 2. That is y is negative 2 and x term is 0. That is what, where is that coordinate will come? That is, sorry, where is that coordinate? That is if y is 0, sorry, x is 0 and y is negative 2, that is in this y-axis. Okay. That is in the y-axis, x coordinate is 0 always and the x-axis, y coordinate is 0 always. So 0 comma negative 2 will be on y-axis. That is x coordinate is 0 and y coordinate is negative 2. Next point is 1 comma negative 2. That is x coordinate is 1 and y coordinate is negative 2 here. Next point 2, 0. Okay, that is this point. Y coordinate is 0 and x is 2. Intersection of both will gives this point. Next we have to draw graph joining these points. Okay, we take another point also here, that is x equal to 3 and y equal to 4. Next we can draw graph. So graph will connect these points, and we can note here that graph intersects at x-axis exactly at 2 points. What are those points? That is x equal to -1 and 2. So what is our conclusion? Here we have 2, 0 and graph intersects at 2 points on at x-axis, which is x equal to -1 and x equal to 2. So graph is intersecting at x-axis at 2 points, that is the 0 of this polynomial, that is x equal to -1, that is graph is touching at x-axis at x equal to -1 and x equal to 2, that is the 0 of the polynomial. So the next problem, p of x equal to x cube minus 4x. So we have to find the zeros here. For that, at first note that x is of degree 3, that is the degree of the polynomial is 3, then p of x is of degree 3, then it has maximum of 3 zeros. Okay, that is the polynomial may have maximum 3 zeros here, that is at most 3 zeros here. So in order to find 0, at first take x cube minus 4x equal to 0. Next, on taking x outside, we will get x into x square minus 4 equal to 0, which implies x equal to 0 and x square minus 4 equal to 0. If x equal to 0, x square minus 4 equal to 0, then we can write x plus 2 into x minus 2 equal to 0. That is x square minus 4 is x plus 2 into x minus 2, which implies x equal to 0, x plus 2 equal to 0 and x minus 2 equal to 0. Hence the zeros are x equal to 0, x equal to minus 2 and x equal to 2. So we have 3 zeros here, that is x equal to 0, x equal to -2 and x equal to 2. Next we have to plot the graph. So our points are when x equal to 0, y equal to 0, that is polynomial is 0, then x equal to 1, then 1 cube minus 4, that is -3, x equal to 2, 2 cube, that is 8, 8 minus 4 into 2, that is 8, which is 0 again, x equal to -1, then -1 cube is -1 itself, -1 into -4 will give +4, -1 plus 4 is 3, -2 cube minus 4 into -2 will give, that is -8 plus 8, that is 0. So we get our points here. Next we have to draw the graph. So at first we can plot the point, that is x equal to 0, then y equal to 0. X equal to -2, then y equal to 0, that is this point. That is x-axis is -2 and y-axis is 0, this point. Next point, -1, 3, that is x is -1 and y is 3, that is this point, that is intersection of x equal to -1 and y equal to 3 is this point. Next point, that is 0, 0, that is this point, that is the center, the origin. Next is x equal to 1, y equal to -3, that is x equal to 1 and y equal to -3 will comes here, here. Next, x equal to 2 and y equal to 0, that is this point. Okay, so we get our graph the points here. Next we have to draw the graph connecting those points. So our graph will be like this. Okay, connecting this point, our graph will be like this. So we can note here that the graph is intersecting at 3 points. Okay, that is x equal to -2, x equal to 0 and x equal to 2 at x-axis. So here we have 3 zeros and graph intersected 3 points in the x-axis, which is x equal to 2, x equal to -2 and x equal to 0. So we can see here the graph is intersecting at x equal to -2, x equal to 0 and x equal to 2. So which are the zeros of the polynomials? Okay. The next problem. P of x equal to x square plus 2. Here the polynomial is of degree 2. It may have at most 2 zeros. Put x square plus 2 equal to 0. That is at most 2 zeros means maximum number of zeros it can have is 2 or minimum it can have is 0. That is it can have no zeros also. Here x square equal to -2. So not possible, real number square cannot be negative. Okay, since x square plus 2 equal to 0, which implies x square equal to -2. A real number square cannot be negative. So what we can conclude here, this has no zero at real line. Okay, that is this polynomial has no zero at real line, or hence there are no zeros for the polynomial. Now we can plot the graph. That is P of x equal to -2, then y is 6, that is -2 square plus 2, that is 6, -1, that is 1 plus 2, that is 3, x equal to 0 means 2, x equal to 1 means 3, and x equal to 2 is 2 square 4, 4 plus 2, 6. So what is our graph? That is, okay, that is first point is x equal to -2 and 6, where is x equal to -2 and 6. So at first we are plotting the point -1 and 3. Okay, what is here is -1, that is here -1, x equal to -1 and y equal to 3. This point. Next point, x equal to -2 and 6, that is this is x equal to -2 and this is 6, that is these 2 points are coinciding here. Next 0, 2, that is x equal to 0 and y equal to 2, this point. X equal to 1 and y equal to 3, that is this point. Now x equal to 1 and y equal to 3. X equal to 1 and y equal to 3, this point. Next x equal to 2 and y equal to 6, that is this point. That is x is 2 and y is 6. It is coinciding here. On drawing graph, we will get a graph like this, which is not intersecting at x-axis, that is which is not meeting any point at x-axis. So what we can conclude, here we have no zeros and graph intersects at no points at x-axis. Okay, not here polynomial is degree 2 but no zeros. That is, if a polynomial is of degree 2, it can have at most 2 zeros, which means it can have no zeros or 1 zero or at most 2. That is, maximum possible number of zeros is 2. Okay, here we have no zeros. Okay, So if a polynomial is of degree n, we can conclude that it can have at most n0. Also it can intersect at most n points on the x-axis, or it can intersect at no points on the x-axis according to the number of 0. Okay. Okay, now what we can conclude? Geometric meaning of 0 of polynomial means the zeros of a polynomial p of x are precisely the x-coordinates of the points where the graph y equal to p of x intersects the x-axis. Okay, that is, the zeros of the polynomial are the x-coordinates of the points where the graph of the polynomial intersects at x-axis. That is, the graph of the polynomial will intersect at x-axis. Next, that is, x equal to a is a zero polynomial p of x if y equal to p of a intersects at x-axis. That is, what we can conclude, if a graph of a polynomial intersects at x-axis, then that point is zero of the polynomial. Okay, that is, if y equal to p of a intersect at x-axis, then x equal to a is the zero of the polynomial. That is, if graph intersect at 1, then x equal to 1 is the zero of polynomial. If p of x is polynomial of degree n, that it intersect x-axis at most n points. If polynomial is of n degree n, then it can intersect at most n points in the graph. So let us see one example. Look at the graphs given below. Each is the graph of y equal to p of x, where p of x is a polynomial. For each of the graph, find number of zeros of p of x. Okay, how to find number of zeros of p of x? That is, at first we have to note where number of points at which the graph is intersecting at x-axis. Then the polynomial will have that much zeros. Okay, here the graph is intersecting at only one point, so this will have only 1 0. That is, this polynomial will only have 1 0. Okay, that is, this polynomial will only have 1 0 since the graph is intersecting at only one point in x-axis. Okay, here we have two intersection at x-axis, that is here and here. So the polynomial will have so the polynomial will have two zeros. Here the graph is intersecting at 3 points, that is 1, 2 and 3. So the polynomial must have 3 zeros. Here, what about here? Here only 1 point, so the polynomial will have 1 0. Here only 1 point, so 1 0. Here 1, 2, 3, 4. So that is, graph is intersect 4 points here with x-axis. Then it must have 4 zeros. That is, polynomial must have 4 zeros here. So the next problem, it's an exercise. The graph of y equal to p of x are given below for some polynomial p of x. Find the number of zeros of p of x in each case. So this is the graph. So we have to find the number of zeros of the polynomial. Okay. So at first look at this graph. Here the graph, that is this line, the graph of the polynomial is not intersecting at x-axis. So number of zeros is here 0. No zeros because the graph is not intersecting at x-axis. Okay. Here the graph is intersecting at 1 point. So number of zeros is 1. 1 0 because the graph is intersecting x-axis at only 1 point. Here we have 1, 2, 3 points. So here we have 3 zeros at the third graph. 3 zeros because graph is intersecting x-axis at 3 points. Here only 2, that is 1, 2. So 2 zeros. Graph is intersecting at 2 points. Here 1, 2, 3, 4. So 4 zeros in the fifth graph because graph is intersecting x-axis at only 4 points. Okay. Here 1, 2, 3, that is 3 zeros because graph is intersecting x-axis at 3 points. So we get our answer here. That is, at first we have to look at the graph and where the graph is, the number of points that the graph is intersecting at x-axis, then that polynomial will have that much zeros. Okay.